Video, we're going to find the zeros in the vertex form of f of x equals 2x squared plus 4x plus 6. So to find zeros, the first thing I'm going to do is I'm going to set the function equal to 0. And typically, if I have a leading coefficient like that, I like to start by taking out a greatest common factor if I can. So it looks like 2 is the greatest common factor, so I'm going to divide by it. So we've got x squared plus 2x plus 3 equals 0. I'm going to see if I can factor that. So I'm looking for two numbers that multiply to 3 and add to 2. My only choice is 3 and 1, and that's not going to add to 2 because I can't make either one of them negative. So factoring doesn't work. So I'm going to try a quadratic formula. So x equals, now I can either use my original or I can use my new one. I'm going to choose to use this one, but it really doesn't matter. So I'm going to go negative b, which is 2, plus or minus the square root of 2 squared, the b squared, minus 4 times my a value of 1 times my c value of 3, all over 2. So we get negative 2 plus or minus the square root of 2 squared is 4. Negative 4 times 1 times 3 is negative 12, all over 2. So we've got negative 2 plus or minus the square root of 4 minus 12 is negative 8 over 2. So when I see a negative under a radical sign like that, I know I need to pluck my eyes out. And then at the same time I'm going to break down that radical, I go to my square numbers list. And I know that it's divisible by 4 2 times. And we're going to simplify that 4. So the square root of 4 is 2. I write 2, the I after it, and square root of 2 over 2. And then finally, I'm going to take out a greatest common factor of 2. So that would be negative 1 plus or minus. I take a 2 out here, I square root of 2 over 2. And then finally, these 2's cancel. You get negative 1 plus or minus I square root of 2. That was a lot of work. So but we still have to find vertex form. So that one actually has imaginary zeros. So technically it's 1 plus, actually you would just leave it like that. So those are your roots, imaginary roots this time. Vertex form is going to be, actually I take that back. It would technically be negative 1 plus or minus I squared of 2 comma 0 because we set that equal to 0. So this is your x value. That's right. And it's going to be weird when you look at the graph. All right, vertex form. So I am going to take this and I'm going to make it y equals 2x squared plus 4x plus 6. Whenever I have a leading coefficient, I know I have to divide by it first. So you get y over 2 equals x squared plus 2x plus 3. I know I take my constant term then and I subtract it to the other side. And then I put in my plus blanks because I'm completing the square. I'm going to set up my cheating factoring. Take the middle term, divide it by 2, so I get 1. Square that, I get 1 to either side. So you get y over 2. What's negative 3 plus 1 is negative 2. Then we've got y over 2 equals, I'm going to take the 2 and add it to the other side. And then we're going to, this is the tricky part because I have a leading coefficient like that, I'm going to multiply all terms by 2 to get rid of it here, to get the y back by itself. Remember, there's 2 terms on the right side. So y equals 2 times x plus 1 squared, and then 2 times 2 is 4. So my vertex, remember I change the sign when I come in or out of parentheses, so that's going to be negative 1, and then I keep the sign outside, so it would be 4.